In this lesson, we will begin with that starter file manipulating fields that you can download below, which will have our different sections empty except for our geometry section, and we'll use these blocks to show the different ways we can manipulate our fields and our geometry. And this is the same concepts that we discussed in the lessons as well too, so a video version of that. I'll begin with talking about that remap field versus remap body, so you can add your cursor there, and we'll add both of those blocks in. So I have a remap scale body that I'll compare with our remap scale field. And similar to in our last follow along, we discussed our remap cylindrical field. We also have that cylindrical body, the spherical body, and remap spherical field. So with all of these, there are pretty similar results that we can see visually. So I'll use this glider implicit body as that example. So I'll place that into both of these. For our X scale, I'll do 3. I'll do 2 for our Y scale and 5 for our Z scale. And I'll do the same for both of these. So note that these are both custom blocks or toolkits already built into that software. So when we were using our scaling before in that example, we had to multiply X, Y, or Z or divide by that certain value we wanted to scale. And if we were doing X multiplied by 0.5, then that would give us something twice the size. With these custom blocks, we just put in a scalar value with no units, and this is going to scale in the way that we expect. So this will be 3 times the size on the X, 2 in the Y, and 5 in the Z. And let me change this color, although you can't really see it anyway. But we'll use that for other options. We can see that this is that scaled version. So just note if you're using these custom blocks, these toolkits, that will act as we kind of expect to be 3 times that size. Now, if we look at our remap scale body, and then I'll go into my block details and change the color of my remap scale field and turn that on, we can see that they give us that same visual result. So this is going to give us very similar, like I said before, one is a scalar, one is an implicit, but the key difference with this is the scalar field that we see inside of it. So if I type F, and I will turn off my visibility for those and add a contour interval of, let's do 10. Let's do 50. So we can see that. I see everything inside is those negative values, everything outside is those positive values. We have 50, 100, and so forth. If I type F to then see that remap scale field other option, we can see that the values have changed slightly. So while the inside and the outside are negative inside, outside positive, just that rate of change within that field is going to be a little bit different if you use that remap scale field. So the reason for this is just because if you go inside this remap scale body, and what you can do is right-click, export that block, and I have an example of that I just saved. What you can see is as well as doing that multiply divide as we had talked about in the last video, we also have the scale factor. So if you're opening up that remap cylindrical body or that remap spherical body, you'll see a different way of getting that scale factor. But either way, we'll have that scale factor, and that's just going to bring it back to the scale of that field that we need. So the reason you might want to do this is, if you're using this as your reference for a ramp or something along those lines, you're going to want to have it smoother transition. So while your implicit body shape will be the same, just that scalar field under the hood in that field viewer will be slightly different rate of change. And with either one of these, we can always go into that property, take out that body as well, or take that implicit body and take out that scalar field. The next thing we'll talk about is orienting and reorienting our bodies, and in this example I'll use our cone. So I'll type I to isolate that, and then type Z to zoom in. And what I'm going to do is use our orient object as well as our remap field. So I'll put my cursor right in there, and I'm going to use our orient object block first. And while I'm looking at this, and it looks kind of straight on the origin, if we actually go to our view and look at our display grid, we can see that this is actually at that angle here. And what I'm going to do is make a mirror of this on the other side, as well as keep this original side as well. So we'll have kind of a cone going out, just like we have in that lesson. If you want to take a look at that, get as well. So for our object that we want to orient, I'll use our cone. And if you're unfamiliar with our orient object, you can learn more about this in our ribbing and texturing course or in our slicing and print layout course. So our object is the cone, and then we have our source plane, what we're originally starting with, and our destination plane. So I'll make both of these variables, and I'll put in a plane from normal for this. If we open up our cone, we can see what that looks like, and just to have it kind of flush on that bottom face, I'm just going to do that normal of 0, 1, 1. And for our origin, there's a couple of things we can decide. So you could decide to go into the cone block details, take that centroid from the bounding box like so. But if we use this as our orientation, and I'll start with this, we're going to see that we will not eventually have anything below this plane. So let's start with that, where I have a plane from normal for my destination, and my destination will be right at that origin. Now the reason that I'm changing this is because whether we're mirroring or something along those lines in this remap, it's going to use the X, Y, and Z axis. So we could change that kind of plane, doing some other manipulation of what that starting field is. But this is another way that we can go about it, is just place that cone in the origin so that it can be quick and easy to manipulate. So I'll right click, make this a variable, and label this cone at origin. Then I'm going to remap this. So I'll do remap field, where this is the object I'm going to remap. And I'm going to create that mirror and keep that opposite side as well. So I can go, I'll keep the X the same, the Y the same. Instead of taking the negative of the Z, I'm actually going to take the absolute value of the Z. So you can see something a little bit different. So if we're looking at the absolute value, I'll put in the plane from normal when typing FW the field to be 0, 1, 0. And contour interval of 50, or 10, 5. Now everything that we see is positive, so anywhere that was below that plane from normal, below that origin, we're going to not have. So if you look at this remap field, it's going to create a double basically. So one as it is with that bottom part removed, and then one at that underneath that and mirroring of that. So if you didn't want this, you could just take that negative Z and you would just have this flipped. If we want to have this right so that we have the entire cone included, instead of using that centroid, I'm going to take this point 1 that was used to create that cone, which is just that, let me close that field viewer, it's just that point here. I'm going to replace that origin of our source plane with point 1. So now it's going to be that same size. We're not going to lose any of that. So this is my cone remap. I'll make this a variable. Let's label that cone remap. And then the last thing that I'll do is orient object and bring this back to its original spot. So before with our orient object, we did our source is our source, destination is our destination, but now to bring it back to where we were, we'll just do the opposite. So for source, we'll put that as the destination, and our destination will be source. So that might be a little bit confusing with those names, so feel free to also change them. In our completed file, I have this as our start plane, and this is our plane at origin. And now if we look at it, and I'll turn on that cone, we can see that we have that bottom and that top as well too. So that's another way that we can manipulate and change, have that mirror or have the absolute value of both. The other thing to note is you could also, instead of using that scalar field option, you could go in and take the body and replace that, and it gives us that same result. So not a difference when it comes to that. Next, we'll talk about sectioning and extruding. And I'll use that glider again as an example, and I'll turn off my display grid. So this is again another way that we can use that remap field. I'll type in remap field. Make sure that's in our section and extrude section. And what I'm going to do is manipulate this plane and just get kind of a profile of it and extrude that. So for my glider, that would be my scalar field I want to change. I want to take that profile in the Z, so X and Y will remain the same. And I'm also just going to take a plane from normal for this, so we can visualize what we are taking that section cut of an extrusion. So we can see that's right at the center of our part. And I will just go into the properties of our plane from normal in the origin and select that C. So by putting in a scalar value, this is going to give us this constant field. So I get kind of a not the exact result that I'm looking for. I'll turn that off because we haven't confined that field. So if I type F, I'll turn off this glider, and I'll change that size to 2000. And what we can see if I move this up is we now just have that same profile throughout our part. So what I can do with this is now do a Boolean intersect, or I could do that set field bounding box. That's what we had done in the last follow along, where I'm going to put that remap field, and I'm just going to set the bounds to be the bounds of our glider. So I can go back into that block details for the glider and choose the bounding box. Inside that bounding box, I'll choose that implicit box version. So now we can see I have that section and extrusion of that center of my part throughout my entire bounding box. And we can change what this profile looks like by just changing that location of the plane from normal. So now we have this cutting through this specific part of the glider, and we can see that is what we are extruding. So another way that we can use that remap field. I'll also talk about spatially varying the shifting and stretching. So going a little bit more advanced from our last video, if you wanted to not only, if you didn't want to just scale constant, or you wanted to scale multiple ways, we can use a ramp for that. So I'm going to put in a remap field. In this example, I'll use that glider again, or we can use maybe we'll use this box from whole. And in this example, I use that box from whole. And to create that variable stretch, I'll use this as my scalar field. And if I want it to have that scaling in the X and the Y and remain constant in the Z, Then I'll have a divide for my X scale, divide my Y, and Z will remain the same. So we're going to divide X by something, Y by something, and what we'll divide is a ramp. So we'll add a ramp block in here, and I'll just use a plane from normal. To show this. And I'm going to look at the field viewer, change the plane from normal to be 0, 1, 0. So I can see what that looks like as you go up my part with a contour interval of 10. So maybe what I want to have is a change in that size from throughout the entire part. So from 0 millimeters right at that plane to 30 millimeters at the end of that part. And I'm going to scale it from 5 to 1 with a geometric continuity. And I'll make this a variable and label this stretch ramp. And I'll use this for the X and the Y. So now if I view this, you can see that was a lot, but what I can do is change that a little bit. Let's try 2, so we have something a bit better to view. And we're going to get that scaling. So in the example in our lesson, we use a diamond TPMS. This example, I'm just using that box hole. And something to note is that we are getting that scaling, but we're only going to have that, as you can see, kind of going out of our part. So this is a good thing to note as well. So if I look at it from that 0, 1, 0, again, that contour interval of 5, what we can note is that because we have that in that negative and our part was only in that positive, we're not going to have that change. It's still going to stay exactly the same right at that center. So we can see some more of a change if we change that location for our box. So if I'm changing this like so, we can see what that would look like. We'll also do a shifting, so we can variably shift this as well, also using ramps. So for instance, I'll add another remap field, and I'll make this original remap field a variable. So I'll right click, make that a variable, and I'll just label this variably stretched. And this one will be variably shifted. So this time, instead of multiplying or dividing, I can scale this. So I'll do that box of holes again. And now I'm going to choose, I'll subtract this time with the X and the Y. So I'll do X, Y, and I'll keep that C the same again. And I'll add another ramp. So this ramp will use the same plane from normal we could do from before. So I'll drag and drop that one holding control so that I have that repeat. Or I could make that plane from normal a variable as well. Again, we'll have that 0 and into 30. So that change of location will be going, I'll turn off that stretch ramp now, and bring this back to 0.1 to be 0, 0, 0. So let's turn out that variable stretch ramp, so we just look at that box of holes. And our outmin, we're going to just shift this over to 2. And this time I'm going to have this as 0 millimeters to 2 millimeters. So with our last ramp, we had this as unitless because we're just scaling that by 2, scaling it by 1, but this time we're shifting by 2. So that's why we're going to have that change. Make this geometric, and I'll turn off that visibility. And actually, to see a bigger change, let's make this 15. So now I'll have that x subtracted by that shift ramp, and same with that y. So now what we can see is that our kind of starting face looks exactly the same, but now it's just going to be shifted over, like so. So another way that we can use those ramps, use those remapping fields options. So I'll close that. And we can also warp by shape fields as well too. So to show this example, I will close that geometry section. We'll use new geometry. And if I go to my Create tab, I'll just grab a box, a cube, and a sphere to show this. And I'll make these all variables by doing that. Right click, make variable, and I'll just label this sphere, cube, box. And our box is going to be the geometry that we'll remap, and we'll remap that box using that cube and that sphere as a reference. So for the length, I'll just make this 1, width is 1, and I'll type I so I only see that box, and type Z so that I have it zoomed in. So again, we'll use that remap field, place that in here, and our box will change. And I'll keep the Y and the Z the same. But this time, instead of adding by a scalar value, I'll add by that shape. So I'm going to add, I'll do X, and I'll add whatever shape I choose. So in this example, I'll use the sphere. And I don't see anything appearing right away. So if I turn off that visibility and instead type F, I'll change this plane from normal to be 0, 1, 0. We can see something like this. So what's happening is that when we had this X, Y, and Z as our reference for creating this box, by adding by the X that sphere, if we type F and have that contour interval of 1, for instance, this is the 0, and that's where that X was placed, like that, right in that center of that box. That's where that X axis is. So we're going to see that it's rotated like so when we have that occur. And the locations that it'll start and end will be different as well. So in order to visualize this, I'll do that set field bounding box, and I could also use that Boolean intersect as well. And by bounds, I'll just put in our bounding box. We can change that as well too, so that we'll see exactly that. So now if I look at this and I look at my sphere, we can see how it has changed and is kind of going through that. To see how that cube changes, we can put that in too. And we're going to add the cube to here. So if I type F, we can see 1. And we can see it's not going to be right at that exact location. And the reason for that is just because, we're adding this to that X. So we're going to now get something like this that is shaped by adding to that cube. And the last thing I'll talk about is just creating bodies from fields. So I'll put my cursor there. I can type I so I don't see anything. And this is where we would use something like the fields. We can see that geometric. We can see the periodic field options, such as that gyroid field, diamond field. And we can use these fields that are infinite based on those equations that create that gyroid field, for instance, and create something like our TPMS structures. So I'll start with that gyroid field, and I'll put in a cell size of 15 and make this a variable labeled gyroid field. So I'll type F to visualize this, and this is just infinite. So this is our gyroid field, but it's going to be going on forever. We have that negative and that positive. And something else to note is if I probe my values, this is also unitless. and is going from -1 to +1. So in order to create a geometry out of this, we can do a Boolean intersect of the area that we want, but we're going to have to add millimeters to this. So I'm going to multiply and put in my gyroid field. So before we had talked about that difference between our remap cylindrical body and remap scale body with the field versions, and just that scale factor is what changes it. So with this one also, we're going to add that scale factor. So in this one, we'll just make this 1 millimeter for now, just so we can see that if I type F, now I'm going to have something that is in millimeters. So I can use this to create a geometry of this. So I'll right click, make this a variable as well, and I'll just say gyroid field with units. So to view this, as we would our TPMS structure, I can do a Boolean intersect of our gyroid field with units, as well as our, we can do our box with hole again. So now, wherever we had that negative field within our geometry, we're going to have that in the space that is our implicit body. And another thing that we can do is we wanted to get that opposite region. For instance, if you're doing something like heat exchanges, this type of concept of using those fields can be really helpful to get the one fluid region and the other. If we go to that gyroid field with units, and we just do instead dot negative and cancel out of that, we're going to have that opposite region. So if I type F, we can now see anywhere that we had that positive field, we're going to now have that geometry. And so just by switching that negative and the positive, we can get something like that. So here are some examples for manipulating fields.